Hi, ma'am.
Hi Naveen, please come.
Yeah,
Sit down.
thank you.
How are you?
Fine, ma'am. How about you, ma'am?
Very good. So your exams are nearing?
Yes, ma'am. Next week we
You are
have exam.
prepared?
Somewhat, ma'am.
Okay. Don't get panicked, Naveen.
Yes, ma'am.
You have prepared well.
Yes, ma'am.
Okay. So we'll have some revision of experiments. The same set of questions, more or less similar questions will be asked by the examiners. Okay, in the
Yes, ma'am.
university exam. Don't worry about it. Okay, we'll have some discussion regarding the basics of hematology
Mm.
experiments. Okay,
Okay, ma'am.
what are the basic equipments that you need for hematology
So,
experiments?
microscopes, glass slides, and RBC chambers,
Mm.
solutions, and pipettes, etc., ma'am.
Do you call it as RBC chamber specifically?
Newbar chamber.
Yes. What Newbar chamber?
Mm,
You should answer.
the
Improved
improved Newbar
Newbar
chamber.
chamber. Okay, it
Yes.
has some revisions. So
Okay,
that is
ma'am.
what the answer expected by the examiner. It
Okay,
should be
ma'am.
improved Newbar chamber.
Improved Newbar chamber.
Okay,
Yes,
fine.
ma'am.
Okay, that's all.
Yes, ma'am.
All the glasswares. Right. Now, what type of microscopy is that?
Light microscope.
What is the principle of light microscopy?
Okay, the light microscope is an instrument for visualizing the fine image by creating a magnified image through the series of lens, which first focuses the beam of light through the object, and then the objective lens enlarges the image that are formed in the microscope.
Excellent. Okay, so I'm just summarizing what you have told. Okay,
Yes, ma'am.
so it's a simple system to magnify the finer details of an organism,
Yes,
preferably a microorganism,
yes, ma'am.
right? And it uses certain set of lenses
Mm.
and a focusing system, and it uses light as the source of illumination.
Yes, ma'am.
If light is not used as a source of illumination, do you know any other types of microscopes?
Mm. Dark field microscope,
Yes,
interference phase microscope,
very good.
and phase contrast microscope, fluorescent microscope, and electron microscope.
Excellent, Naveen. Very good. Okay. Now, what is the difference between a simple microscope and a compound microscope?
Mm, Simple microscope has only one lens, and it does not have the condenser, ma'am.
Okay.
And it has only the concave mirror, ma'am.
Okay.
Whereas in the compound microscope, we have two set of lenses, ma'am. That is the eyepiece and the nosepiece, ma'am.
Mm.
And it has 3 to 5 lenses. It has the condenser, and it has both concave mirror as well as the plane mirror, ma'am.
Okay. Very good. What microscope that you are using in the lab?
Compound microscope,
Okay. How many lenses were there in that?
3 lenses, ma'am.
Okay. Very good. Okay. Now, what are the parts of the microscope?
Okay. So basically we have the 4 parts. So first one is the supporting system, and second is the focusing system. Third one is the optical or magnifying system, and fourth one is the illuminating system.
Very good. In the supporting system, what are the parts you have?
We have base, pillars, handles, and the body tube and stage, ma'am.
Okay. Coming to the stage, are there any types of stage?
We have mechanical staging and as well as fixed staging, ma'am.
Yes. How the mechanical stage moves?
It moves in horizontal or vertical direction, ma'am.
Okay. Tell me about the magnification system, Naveen.
So for the magnification, we have the lenses, ma'am.
Mm.
So 3 types of lenses we have. 3 powers of lenses. One is the 10x, 40x, and 100x, ma'am. So
Okay.
10x will be the low power, and 40x will be the high power, and 100x will be the oil immersion, ma'am.
Okay.
Highly magnified image.
Very good. Very good. In some schools or some colleges, you have 4x also.
Oh,
Very low power it is called.
okay.
Okay. And many of the students will answer this wrongly. What is high power? If we ask, they will answer 100x is the
Okay.
high power. That is not right.
Okay, ma'am.
High power is 40 or
40x.
sometimes 45x.
Okay, okay, ma'am.
Low power is 10x.
10x.
Very low power is 4x. Okay. What is that x means here?
So magnification.
Yes, that much times the magnification. 4 times the magnification of the object.
Yes,
Like that. Okay, fine. Tell me about the illuminating system.
So in the illuminating system, we have the either inbuilt light or the external source of light, and we have the mirrors, that is the concave mirror or plane mirror,
What is
And
the purpose of the mirror?
it reflects the lights, ma'am.
Very good. Okay.
And we have the diaphragm, there's iris diaphragm and the condenser, ma'am.
What is this condenser made up of?
So condenser is made up of different types of lenses, ma'am.
Okay. It's actually the spherical lens only.
Spherical
And
lens.
any
Okay.
particular name for that condenser lens?
AB.
Very good. Excellent. This is a star question. So the condenser uses AB type of lens system.
Yes, ma'am.
Okay. It's again a convex lens. Right. Okay. What is the purpose of this iris or diaphragm?
So it basically focuses the light, ma'am. It adjusts the light.
It adjusts the amount of the light that
Light.
is falling on the object.
Yes,
Do you
ma'am.
have any similar system in our body? What about the pupil of the iris?
Pupil. Yes, ma'am. Yes.
Okay, pupil constricts and
Dilates.
dilates. In fact, the muscle that is constricting the pupil is called as iris, right?
Yes, ma'am.
Okay, the same purpose
Okay.
in the microscope. Okay, fine. Now let us get into some depth of the optics of the light.
Okay, ma'am.
Right. What is resolution power?
So resolution power basically it's the ability of the lens to reveal the adjacent structure as clear and as separate and distinct, ma'am.
Does this sound similar anywhere in our body?
Yes, ma'am. It's more or less similar to the visual acuity, ma'am.
Exactly. Very good. Okay. So, what is numerical aperture?
Numerical aperture is the ratio of the diameter of the lens to its focal length, ma'am.
Yes.
And it is the index of resolution power.
Very good. Okay. Now, if the numerical aperture is more, how will be the resolution power?
Will be greater, ma'am.
So, which lens system has got the greatest numerical aperture?
Oil immersion.
Excellent. Very good. Okay. Now that we have got different types of lenses,
Yes, ma'am.
okay, can you tell me the total magnification by each lens?
Okay. For 10x, it is 100.
How 100? It is only 10 times
Yes.
magnification, right?
So 10x and no, the eyepiece has 10x, ma'am, and we have the objective lens. It has 10x. So 10x and 10x we have 100x, ma'am.
100x. Very good. Similarly, for high power,
High power we have 400x, ma'am.
okay,
So it's eyepiece have 10x and
objective.
objective we have 40x. So it
Okay.
is 400, ma'am.
For oil immersion,
It's 1000, ma'am. 10 into
Yes.
100.
very good. Okay. Now, can you tell me the microscopic adjustments that are to be done for using each objective lens?
Yes,
Now, how
ma'am.
will be the low power focused when what adjustments you will make in the microscope?
So in the mirror, we use a concave mirror, ma'am, and the condenser position should be at the lowest, and the diaphragm should be partially opened.
Okay, fine. For high power,
So high power, we use the convex lens, and the condenser is partially raised, and diaphragm is partially opened, ma'am.
okay,
So for the oil immersion, we use the plane mirror, and the condenser is fully raised, and the diaphragm is fully opened, ma'am.
pakka, fine. Now that you have answered most of the questions in
Yes,
the
ma'am.
microscope, I'm coming to the star question.
Yes, ma'am.
Okay, let me see if you're answering this. Okay, what is power focal system?
Power focal, I think it's basically related to the objective lenses, ma'am.
Yes. Can you guess it?
No idea, ma'am.
Okay. Now, if you have seen in our lab, the nose piece has got 3 objective lenses.
Yes, ma'am.
10x, 40x and 100x.
100x.
If you see that height of the lenses, the oil immersion has got the shortest height
Yes,
or
ma'am.
length. Okay. Whereas the 10x will be longer. It will be somewhat taller. Okay. Now, this is made in such a way that if you focus with one objective lens clearly, and if you change the lens to the other objective, then also the focus will be there. The
Oh.
image will be still focused.
Yes, ma'am.
All that you have to do is making some finer
Fine
adjustments to
adjustments.
make it clear. That's it.
Yes, ma'am.
So the height is adjusted in such a way that each image, each lens focuses the image without changing the coarse adjustments.
Oh,
across.
okay.
It's almost like using the progressive lenses for the treatment of presbyopia.
Presbyopia, yes.
Okay, the progressive lenses are used for both near vision and distant vision, right?
Yes, ma'am.
So similar to that,
Yes, ma'am.
right? Okay, so that is power focal system. I hope you got it.
Yes, ma'am.
Okay. What is working distance?
Working distance is the distance between the objective lens and the object, ma'am.
Mm-hmm.
So for the low power, we have 5 to 15 mm, and for the high power, we have 0.5 to 4 mm. For the oil immersion, it is 0.15 to 1.5 mm, ma'am.
Okay, fine. Fine. Another star question.
Yes,
What
ma'am.
is racking the microscope?
Uh, to visualize the three dimension of the organisms, so we do fine adjustment by dragging it back and forth once the object is being on focused.
Okay. So this way, in fact, it can differentiate between the dust particles and the cells
Oh,
also. Okay.
okay, ma'am.
So that is called tracking.
Okay, ma'am.
Very good, Naveen. You have prepared well to start up with microscope. You have answered most of the questions. We will proceed further with all other experiments of
Sure, ma'am.
immunology actually. Okay.
Thank you.